Condensers. Condensers and evaporators are basically heat exchangers during which the refrigerant undergoes a phase transition. Next to compressors, proper design and selection of condensers and evaporators are extremely important for the satisfactory performance of any cooling system. In condensers, the refrigerant vapor condenses by rejecting heat to an external fluid, which acts as a heat sink. Normally, the external fluid doesn't undergo any phase transition, except in some special cases like in cascade condensers, where the external fluid, another refrigerant, evaporates. In evaporators, the liquid refrigerant evaporates by extracting heat from an external fluid, low-temperature heat source. The external fluid might not undergo a phase change, for instance, if the system is employed for sensibly cooling water, air or another fluid. Working of condensers. The condenser is a crucial component of any cooling system. During a typical refrigerant condenser, the refrigerant enters the condenser during a superheated state. It is first superheated then condensed by rejecting heat to an external medium. The refrigerant may leave the condenser as a saturated or a subcooled liquid, depending upon the temperature of the external medium and style of the condenser. As shown in the figure, the warmth rejection process is represented by 2 to 3 up to 3 to 4. The temperature profile of the external fluid, which is assumed to undergo only sensible heat transfer, is shown by a dashed line. It is often seen that processes 2 to 3 may be a superheating process, during which the refrigerant is cooled sensibly from a temperature T2 to the saturation temperature corresponding to condensing pressure T3. Process 3 to 3 is the condensation process, during which the temperature of the refrigerant remains constant because it undergoes a phase transition process. However, at the present for simplicity, it is assumed that the refrigerant used may be a pure refrigerant, or an azeotropic mixture, and therefore the condenser pressure remains constant during the condensation process. Process 3 to 4 may be a sensible, subcooling process, during which the refrigerant temperature drops from T3 to T4. Classification of condensers. Based on the external fluid, the condenser can be classified as A. Air-cooled condensers, natural convection type, forced convection type. B. Water-cooled condensers, double pipe or tube-in-tube type, shell and coil type, shell and tube type. C. Evaporative condensers. This is it for today's video. Let us know in the comment section which topic you want to see next. Before leaving, check the exclusive offers, link in the description below. And do not forget to hit the like and subscribe button. To find out more on the subject, continue watching the next video.